Hello there, this is Ms. Page. In this lesson, we are going to talk about how to multiply polynomials of higher degree. So we're adding on to what we already know about multiplying polynomials. Higher degree means that our power is going to be larger than what we've dealt with before. This would include, so before we've dealt mostly with polynomials with a degree of 2 or 3, like x squared, x cubed. We're going to add to that higher powers, and we are going to be with polynomials that have more than one variable. And so we're kind of looking at some of those right here at the beginning, but these are monomials. So monomials, if you recall, is a word that we use to describe when only multiplication of numbers and variable powers is involved. And there's no distributing when we multiply monomials, because distributing is something we do across addition or subtraction. So when we go to multiply monomials, we need to use what we call the product of powers property. And this means we're multiplying powers together. And so it tells us if we have two powers of the same base, these are both base x that we're multiplying together, we will combine those into one new power of x by adding the exponents together. And this rule, it's helpful to kind of understand where this rule comes from. It helps you remember it better. So for example, if you've got like a squared times a cubed, if you expand these, this is a times a, and then a cubed is multiplying 3a's together. So this is a times itself 5 times. And we know if we multiply anything times itself a certain number of times, that's a to that power, which would be 5. And notice that the 2 plus the 3 does also give us that exponent of 5. So that's where this addition rule does come from. So when I am multiplying, say with this problem right here, these two monomials together, I have my coefficients of 9 and negative 5, which I will multiply together like normal. That's going to be a negative 45. And then I'm going to look at this by organizing my like powers together. So my 2 powers of x, and then my 2 powers of y. And then I apply this product of powers property. So x to the 5th times x to the 3rd becomes x to the 8th from the 5 plus the 3. And remember that y does have an exponent of 1. It means first power. So we do the 4 plus the 1 there to give us times then y to the 5th. And so this then becomes our simplified product or polynomial. In this second one, the big difference is simply that there are no parentheses around this first polynomial because they're not required. It does mean the same thing. And so this is still a monomial times a monomial. There's no addition, there's no subtraction. So this is, take the negative 2 times the 5, which are the coefficients, which is going to give us a new coefficient of negative 10. Grouping our like powers, we have an x squared and an x to the 7th. We have a y, and then we have z's. And notice I did put them in alphabetical order. So I add the 2 and the 7, which now gives me x to the 9th. The y, just going to stay a y because there aren't any other y. Oh, it's a y to the 6th. Almost lost that. Y to the 6th is going to stay the same. And then I have these z times z, which remember would both have exponents of 1. And adding those together then gives me z squared. So there is my final polynomial, which is a monomial, all multiplication. Here's another type of monomial problem. This is taking the monomial that's inside the parentheses and raising it to an exponent. So this uses another exponent rule that you might recall. It's called power of a power. Or power of a product. Product if you have two things, like 2 or more things multiplied on the inside. So if I've got, say, a b to the power of n, then that n becomes the exponent on both the a and the b. That's the power of a product. Power of a power says, okay, if you've already got an exponent other than 1 inside, well, let me use something other than a number. and you have two exponents on the same base, here that base is a, that to combine these two exponents together we would multiply them, and that's power of a power. So both of those things are applied in a problem like this one. Now notice that inside your parentheses you do have two powers of a. You can combine those now or you can combine them later, but in your final answer you should have only one power of a. So I like to combine them now. I think it's easier. So those would combine through power of a product, and so, or product of powers. And so we would add those together. So I would simplify this: 2 times a to the 6th power, b to the 5th power is now cubed. Now every factor, the 2, the power of a, and the power of b, are all going to be raised to this exponent of 3. So we have 2 to the 3rd power times our a to the 6th to the 3rd power times our b to the 5th to the 3rd power. Now with the 2 to the 3rd power, remember, that's basic math. That means 2 times itself 3 times. That's 4 times 2, which is 8. With the power of a and the power of b, we are now using power of a power, which says that we combine the exponents by multiplying. So the 6 times the 3 gives us 18, and the 5 times the 3 gives us 15. So here is our final simplified polynomial, or monomial. Here's a practice problem. I would recommend that you pause the video, try this one, come back to check. Let's take a look at the result. So compare yours. Here we would be adding exponents, but our coefficients, -8 and -3, are multiplied together. And remember, a negative times a negative is a positive. Here's another practice problem. Pause the video. Let's take a look at the result. So in this one, we are using our power of a product. So we would want to combine the two powers of y, which does give us a 3 plus 1 to become a y to the 4th. And then everything inside gets that outside power of 4. And so 2 to the 4th, remember, 2 times itself 4 times, would be 4 times 4, which is 16, or 8 times 2, which is 16. And then the 7 and the 4 and the 4 and the 4 we multiply to give us a 28 and 16 exponents. All right, so now doing another one together. Here's where we have a product. We know that we're multiplying because where the two parentheses come together, we don't see a plus or minus sign. So that does mean we're multiplying. Here we have a binomial times a trinomial, 2 terms times 3 terms. And this, what I'm going to do here first, isn't absolutely required, but it does often make the procedure and getting the final answer into its standard form a whole lot easier. So I am going to rewrite the problem first, so both of these polynomials are in standard form. The first one, x squared minus 3, is in standard form, but the trinomial is not. So the first thing I'm going to do is rewrite this trinomial in its standard form, which would be a positive x squared minus 2x plus 1, because the 1 is positive. So now we would use our distributive property. So this x squared gets distributed or multiplied times the trinomial. And then this -3 gets multiplied or distributed to the trinomial. When I multiply x squared times x squared, remember I am using that product of powers, which says I add exponents. So here I'm going to take the 2 plus the 2. So that gives me x to the 4th. Then I have this x squared times this -2x. That's going to give me a 2 exponent plus a 1 exponent. So I get a -2x to the 3rd power. Anything times 1 is itself, so now I get a plus x squared. Now the strategy I'm going to use now is not required, but I do like to, at this point in these bigger multiplication problems, line my like terms up vertically, but you can also just write them all in a horizontal line. So my -3 times x squared gives me a -3x squared, which is a like term there. And then I have -3, remember, times a -2x, negative times negative being positive, so it gives me a plus 6x. and then negative 3 times 1 gives me a negative or minus 3. So now I combine my like terms, which I've only got these ones in the middle, and that gives me x to the fourth minus 2x cubed. This is a 1 plus a negative 3, which is a negative 2x squared, plus 6x minus 3. And so having started in the beginning doing step 1 by rewriting everything in standard form, my final answer nicely turns out to automatically be in standard form. So I don't have to worry about rewriting it in standard form, because if I start with standard form, I will end with standard form. All right, so here we're just taking this up to, instead of a binomial times a trinomial, we have a trinomial times a trinomial. So I would do that first thing first of making sure they're both in standard form. The first trinomial is in standard form because its powers are descending, but the second one is not. So my positive 5x squared should be first, and then my minus x, and then my positive 2. So now I would start distributing. Now, in this previous example, so in this problem, remember how we had 2 terms times 3 terms, binomial times trinomial? So it's like taking 2 times 3, which gives you 6. So we ended up with 6 different terms down here, 3 and 3. So keep that in mind when you're multiplying large polynomials together. So in this example, we're taking 3 times 3, so we should end up with 9 terms before we do any combining. So the first time we would distribute our x cubed to the 5x squared minus x plus 2. Then we would distribute that negative 3x to the 5x squared minus x plus 2. And finally, we would distribute this positive 1 to the 5x squared minus x plus 2. So going back to the x cubed and distributing it, remember that we would be adding the powers of x together, 3 plus 2. So that gives us 5x to the 5th. And then x cubed times negative 1x, we're adding a 3 and a 1, so that's a negative x to the 4th. If we take a power of x times a number, then we just end up with that product, so plus 2x cubed. So now I'm moving to distributing the negative 3x. So negative 3 times 5 gives me a negative 15. And here x has an exponent of 1, so I'm doing 1 plus 2, which is 3. So that's an x cubed. So I'm going to put that one here, negative 15x cubed. Negative 3x times negative x, which also has an exponent of 1, then negative times negative is positive, so that gives me plus a 3x squared, which doesn't match anything I have so far. And then negative 3x times 2 gives me a negative 6x. So now I'm going to distribute the 1. And so anything times 1 is itself, so I get a plus 5x squared, which matches here for like terms. And a minus 1x, which matches here. And then negative 1, or positive 1 rather, times 2 gives me a plus 2 at the end. So now I've got everything all nicely lined up with our like terms, so I just add those, combine those like terms straight down, and I'll end up with my final answer, and it will be in standard form. So here 2 and negative 15 gives me negative 13x cubed. 3 plus 5 gives me plus 8x squared. Negative 6 plus negative 1 gives me a negative 7x plus 2. And so we got it all done. And notice I had 9 terms here before I combined my like terms. 3 plus 3 plus 3. Here's a practice problem. I would encourage you to pause the video, give it a try, come back and check. Let's take a look. So notice here are the 9 terms that we should have before we combine, lined up with their like terms. And then this becomes our final answer, already in standard form. All right, so here we are multiplying a binomial and a trinomial again. The difference here, as we can see, is that we do have terms that have multiple variables, x's and y's, and we have a mixed, here we have an x term of 3x and an x term of 2x squared, and then we have this y term of 7y squared and a y term of 7y, and we've got this xy, so we've got lots of different things happening here. So I'm just going to go ahead and start multiplying these and deal with then my the standard form at the end here. These are both actually in standard form, in case you were wondering. So we'll end up with standard form if I keep things in this order. So I'm going to start by distributing the 3x to the 2x squared minus xy plus 7y squared. And then I will distribute the negative 4y to that trinomial. So again, now I have to pay attention here to whether the variables are the same also. So here they're both powers of x, so I do combine adding exponents. So this is going to give me 6x to the third power. When I take the 3x times the negative xy, I'm adding the exponents on the x's. So this is going to give me 3 times negative 1, which is negative 3. X times x would be x squared times this y. So you might want to go a little slower with these problems just to make sure that you're getting everything combined correctly, you're not losing things like this y, all that kind of stuff, which are common mistakes. Then I have the 3x times the 7y squared. So I can multiply the 3 and the 7 to give me a plus 21, but I cannot add the exponents because I have an x and a y. The order would be alphabetical, so my x should go before my y squared factor. So I get 21x y squared for that one. So now I'm going to distribute the negative 4y. So I get a negative 8, and here I've got y times x squared. Those again, I can't add those exponents together because one's y, one's x. But when I write them, I should write the x term, or the x factor rather, first, because it's alphabetical for standard form with an individual term. So I get negative 8x squared y, which matches this one right here. So I'm going to line them up. Then I take my negative 4y times this negative 1xy. So I have a negative 4 times negative 1, which is 4. Here I have a y times a y. So I can add those exponents on those y's to combine them. And I should have the x first still because it's first alphabetically. So that's going to give me 4x and y squared for the 1 plus 1. So I have, that matches this one. So I have plus 4x y squared. And then I take my negative 4y times the 7y squared, and those are both y's, so I can add those exponents. That becomes negative 28y to the third power, or y cubed. So now, combining the like terms that I have, and I get my standard form final answer, 6x cubed. Negative 3 and negative 8 is negative 11, x squared y. 21 and 4 gives me plus 25, xy squared. And I end with negative 28y cubed, like so. All right, here is a practice problem for you to try. I pause the video, then come back to check. Let's take a look at the result. So compare yours to what is here. Make sure you didn't make any errors. All right, let's take a look at this problem. So in this one, here's our problem here. We have a binomial to the third power. We have dealt with problems where we had binomials to the second power, like if we had x minus 2 quantity squared. We have learned that there's no shortcut here. You can't distribute the 2 because of the minus sign, so that doesn't work. We have to look at this as x minus 2 times another x minus 2, which is what the exponent means, times itself, and distribute. The same thing is true here because of that minus sign, or if it was a plus sign. There is no distributing of the power of 3. That was a product property, remember. So like if I had 3xy, a product to the third power, then yeah, I can do that. But I cannot do that over here. that would be bad. So now what I am looking at is expanding this out. So I have 3x minus 4y times itself 3 times. Now, the rules of multiplication say that I have to multiply 2 of them together at a time. So I can only start with 2 of them. Doesn't really matter which 2 to start with. I just kind of start with these 2 because then that will give me a binomial times a trinomial, which is the structure I prefer, but it's not a big deal either way. So when I multiply these 2 together, I get 9x squared, and then I get minus 12xy. This will give me another minus 12xy, and then the negative 4y times the negative 4y. Be super careful. Negative times negative is positive. 4 times 4 is 16. Y times y is y squared. Lots of errors with that last multiplication. So remember, 2 negatives never make 0. 2 negatives never make a 0. So this is 9x squared minus 24xy plus 16y squared. So now this is my trinomial, and I'm going to multiply it now times my third 3x minus 4y. So now this becomes similar to a problem that we did earlier. So I'm going to distribute the 3x. So I'm going to get 27x to the third power, adding those exponents. 3 times negative 24. These are technically no calculator problems, so that's a negative 72. X's, I can add the exponents, giving me x squared, then times the y. And then the 3x times the 16y squared. 16 times 3 is a positive 48. And x times y squared is still xy squared. Then distributing the negative 4y, I'm going to get a negative 36 x squared y. Negative 4 times negative 24 will be positive. What it is, let's find out. 96. So I get plus 96 x, and y times y, remember I'd add those exponents, so that's an xy squared. And then the negative 4y times the positive 16y. Negative 4 times 16 is a negative 64. Y times y squared would be y to the third power, the 1 plus the 2. So now I've got everything lined up like terms. At combining, I end up with my standard form, 27x cubed minus 108 x squared y. 48 plus 96 is 144, so plus 144 xy squared minus 64y cubed, like so. All right. Here's a practice problem. Pause the video and give this one a try. Let's take a look at this result. All right, so here it shows we expand it to multiply it by itself 3 times. Then these 2 are multiplied together first, distributing to get that trinomial, and then the distributing of the binomial with the trinomial is shown here with the like terms, and then the final standard form answer. All right, that does finish up this lesson on multiplying polynomials of higher degree. I hope you have a wonderful rest of your day.